Hi friends, here in this video I'll be explaining the problem on assignment. So let's get started. Now here is the question in front of us. It is given that 5 wagons are available at stations 1, 2, 3, 4 and 5. So first, second, third, fourth and fifth. These are the stations given and these are required at 5 stations which are first, second. These are given in terms of Roman. So we have to transfer the wagons from one station to another. The mileages between various stations are given below. So whatever are given in this table or these cells, these are the mileages which have to be covered from one place to another, or we can say the distances. Now, how should the wagons be transported so as to minimize the total mileage covered? It means we have to minimize the cost over here. So the stations, and these are wagons which are to be also transferred to some stations. So the 5 wagons are to be transferred and we have to minimize the cost. So let's get started with the problem into the solution part. I would be drawing the table again. Now the method which we are using it is also called as the Hungarian method, and first of all we have to check if the number of rows and columns are equal. If the rows and columns are equal, that is the problem of a balance type, and if the rows and columns are not equal, then we have to either add a dummy row or column, but in this case it is not required because we have 5 rows and 5 columns. And then look at the first row, select the minimum value, like for example it is 5, subtract 5 from each of the elements over here. So I am subtracting 5 from each of the element and writing the first row. So the first element is 10, 10 minus 5, that is 5, next 5 minus 5, 0, 9 minus 5, that is 4, 18 minus 5, 13, 11 minus 5, that is 6. Because we have to assign, or we have to keep 1 0, at least 1 0 in each of the row and each of the column, so that is why we are subtracting the minimum element. Then in the second row, 6 is the minimum value, subtracting 6 from each term, so 13 minus 6, that is 7, and so on. Next, the third row, minimum value is 2, subtracting 2 from each and every term. Next, we have 9 as the minimum element in the fourth row, so subtracting 9 from each term. Then in the last row, 6 is the minimum element, subtracting 6 from each term. Now we have to also check that if there are zeros present in each and every column or not. Means we should have zeros in each row and each column. So first row is having 0, second, third, fourth and fifth. All the rows are having 0. Now when we look at the column, second row is having 0, third is having, then there are no zeros in the first row, fourth and first column, fourth and fifth column. So we have to have zeros in each of the column. So for that also we have to draw the table again and assign zeros in the respective columns. So this table would be drawn again over here. First, I'll write those columns in which zeros are already present. So that is the second column, third column. That's it. Now, when we check the first column, take the minimum value which is 1 and subtract 1 from each of the elements. So 5 minus 1, that is 4. 7 minus 1, that is 6. 1 minus 1, 0. 9 minus 1, 8, 5 minus 1, 4. Then in the fourth column, the minimum value is 2. Subtract 2 from each term. 13 minus 2, 11. 6 minus 2, 4. 2 minus 2, 0. 8 minus 2, 6. 13 minus 2, that is 11. Then the last column, minimum value 4. So 6 minus, minimum value is 3, not 4. So 6 minus 3, that is 3. 8 minus 3, 5. 3 minus 3, 0. 6 minus 3, again 3. And 4 minus 3, that is 1. Now we see that zeros are present in each row and each column. So we can start with the assignment. So into the first row, select the first assignment. Now this assignment has been made, that is draw a box along this 0. And at the same time see that no other 0 is present in this row or column. So in the first row no other 0 is present, but we look into the column, there are zeros present. So cancel those zeros, because assignment is to be made in such a way that no other 0 is present in that particular row or column in which already the assignment is done. Next, second row. Here the assignment is made. No other 0 is present in this row or column, so that is fine. Then in the third row, I am selecting the assignment over here. Then there are zeros present over here, so these may be cancelled. No other 0 should be present in the row, and there are no zeros in this column. So we can see that assignment is made only in 3 rows. The remaining 2 rows are left without any assignment. So the next step would be tick mark the rows in which assignment is not made. Assignment is not made in the 4th row and it is not made in the 5th row. Then corresponding to these row, like for example, in the 4th row, see if there is any cancelled 0. So in the 4th row, yes, there is a cancelled 0. So this cancelled 0 belongs to a column, tick that column. Similarly, see the last row, and in that also check if there is any cancelled 0. So yes, there is one cancelled 0, so that is corresponding to another column, and they are corresponding to the same column, like 4th and 5th rows. The cancel 0 is corresponding to the same column. Then in that marked column, select a row in which assignment is made. So when I see this marked column, assignment is made in the first row. So I am going to tick mark over here. Now draw the lines which are not tick marked, that is, draw line passing through the rows which are not marked. So first, 4th and 5th are being marked, but we can see 2nd and 3rd, they are not ticked. So drawing light lines through the 2nd and the 3rd rows. Then the marked or tick marked column, draw a line through it. Now here we see there are 2 horizontal lines, one vertical line. It means in total we have 3 lines, and these lines should correspond to the assignments made. So yes, there are 3 assignments made and 3 lines present. Now I have to draw the table again. Next, how to fill this table? First, check what are the uncovered values. Uncovered values means which are not covered by these lines. So we can see 4, 4, 11, 3, 8, 3, 6, 3 and 4, 8, 11 and 1. These are the uncovered values. Out of the uncovered values, take the minimum value. So the minimum value is 1 and subtract 1 from all the uncovered values. Example, 1, when it is subtracted from itself, it will give the value as 0. Then 3 minus 1, that is 2. Next, 6 minus 1, that is 5. We have to write it in the same cell. 11 minus 1, that is 10. Next, 8 minus 1, that is 7. 3 minus 1, that is 2. Next, 3 minus 1, 2. 11 minus 1, that is 10. 4 minus 1, it is 3. And 4 minus 1, it is 3. Next, 8 minus 1 in 4th row, first column. So 7. Then 4 minus 1, which is 3. Next, after writing all these uncovered values, I have to go for the intersection point. Intersection point means here we can see in the second row and second column there is intersection point where they are meeting. So in that, add the minimum element. The minimum element was 1. So add 1 in this cell. Here we are having value 3 at the intersection. So 1 gets added, it becomes 4. Similarly, look for the other intersection over here. It is in the third row and second column. So there is value 0. Add 1 over here. So it becomes 1. Then the remaining values will remain as it is, which are crossed by the lines. So the table has changed. Now make the fresh assignments over here. So when I am making an assignment in the first row, there should not be any other 0 in this row or column. They must be cancelled. In the second row, the assignment is made over here. Also, no other 0 should be there in the corresponding row and column. They are not there. Then when I'm making an assignment in the third row over here, there are zeros present. They may be cancelled. No other 0 should be present in this row or column. Then at last, in the fifth row, fifth column, a 0 is assigned. But there are no other zeros in this column or row. So this assignment is correct. But even now when we see here, there is a row which is left without any assignment. So it means the problem is incomplete. We have to complete the problem. So for that also the step is tick mark the row in which assignment is not made. It is not made in the fourth row. So tick mark that row. Then in that row, check if there is any cancelled 0. Yes, there is a cancelled 0. Cancelled 0 is corresponding to the column. Tick mark that column. After marking that column, see if there is any assignment in that column. Yes, there is an assignment in that column over here. So tick mark the row which is corresponding to the assignment. Now once we have done this, after that we have to draw the lines, and lines should be drawn along the rows which are not there in this marking. So we have to neglect the first and the fourth row. So draw the line corresponding to second row, it is not marked, third row not marked, and the final fifth row which has not been marked. So there are 3 horizontal lines. Then draw a line corresponding to the marked column which is tick marked. So a vertical line. It means for the row we have to draw the lines which are not marked, and for column we have to draw a line through the marked column. So now when we see there are 3 horizontal lines and 1 vertical line, in total we have 4 lines. 4 lines means we have to have 4 assignments, and yes, there are 4 assignments over here. So now the table will again change. So I am going to draw the table again over here. Now I have to again complete this table. For that, see the uncovered values again. Uncovered values are those values which are not cut by these lines. So 3, 3, 10, 2, and then there is 7, 2, 5 and 2. So the minimum value is 2. Subtract 2 from each of the element, that is each of the uncovered values. So 3 minus 2, that is 1. 3 minus 2, again there is 1. 10 minus 2 is 8, and 2 minus 2 is 0 in the first row. Then the next uncovered value is 7. So 7 minus 2, that is 5 in the fourth row and first column. Then over here, fourth row and third column, 2 minus 2, that is 0. Then fourth row and fourth column, it is 5. So 5 minus 2 is 3, and 2 minus 2 is 0. So these are the uncovered values. Next, go for the intersection. Intersection means where the lines are meeting, horizontal and vertical lines. So now go for the intersection. Like for example, when we see the second row and the second column, there is intersection point at this element which is 4. So like the minimum element was 2 over here, this will be added at this intersection point. So 4 plus 2, that gives us 6. Then we have another intersection in the third row and the second column. So 1 plus 2, which is 3. that is third row and second column. Then there are no other intersection points. It means whatever is remaining, like for example this cancelled row will remain as it is. So we have 6, 0, 4 and 5. The next row we have 0, 2, 0 and 0. Then we have this column, in that we have 0. Then we have 0 and 0 which are left. In this row it will be repeated as it is. Then we have to make the fresh assignment over here. So again, when I'm making an assignment, in the first row there should not be any 0 in this row again and in this column. So the assignment is made successfully over here. Into the second row the assignment is made, so there should not be any 0 over here. It is not there. In the column, yes, 1 0 is present, it should get cancelled out. Then in the third row, yes, there is a 0 present over here. No other 0 in this column, but in the row the zeros are present, so cancelling these zeros. Then here we have an option, either we should select the fourth row or the fifth row. If suppose I am making an assignment in the fourth row, then no other 0 should be there in this column. Here 0 is present, it should get cancelled out. No other 0 is there in this row. It means again we are left with one assignment, that is in the fifth row. No assignment is made. The remaining 4 rows have been completed. So we have to again draw the table, and for that the sequence will remain same. Tick mark the row in which no assignment is done. Then in that row check if there are cancel zeros. Yes, there are 2 cancel zeros. So tick mark the column for the cancel zeros. For that cancel zeros, check if there are assignments made in the rows. So when I check this column, yes, assignment is made over this row. Then when I check this column, the assignment is made over here, this row. Now I have to draw the lines which are corresponding to or which are not marked by these rows, that is leaving first and fourth. I would be drawing lines through the rows which are not tick marked. So 2 rows are there. At the same time, there are 2 columns which are marked. So draw the lines through the columns which are marked. So for rows which are not tick marked, that we have to draw the lines, and for columns, the marked columns should be drawn. Now again check the uncovered value, and when I see the uncovered value, 1 is the least value, so subtracting 1 from all the values, drawing this table again. Now again I need to fill this table. For that, the least uncovered value is 1, we can see here. So 1 would be subtracted from all the uncovered values. 1 minus 1, that is 0. Next 1 minus 1, there is 0. 8 minus 1, that is 7. Next uncovered value is in the fourth row, first column. 5 minus 1, that is 4. 3 minus 1, that is 2. And here we have 3 minus 1, that is 2. And then 10 minus 1, that is 9. 7 minus 1, that is 6. And here we already have 0, 0. And now go for the intersection. Like for example, in the second row, second column, we are getting intersection at 6. So add the minimum element, that is 1 over here. So it will be 7. Then another intersection is over here, which is 3. So add the value, that is 1. This will give me 3 plus 1 as 4. Then this same column would be written as it is, so 0. The row would be remain as it is. So 6, 0, 4 and 5. The next row would also be repeated, and the last column would be repeated. Now start making the fresh assignments again. So when I am making an assignment in the first row, first column, the remaining zeros are to be cancelled in that row and column. Then in the second row, no other zero should be present in the row or column after making the assignment. Then when I make an assignment in the third row, no other zero should be present in that same row or column. Next, in the fourth row, if I am making an assignment over here, no other zero should be present in that row or column. And then in the final fifth row. So now we can easily see that all the assignments have been done correctly, and the solution would be written, that is, the answer would be in this way. Like the question was, we had 5 stations on one side, the stations were there, and on the other side also we had stations, that is from one station to another. On one side we have stations 1, 2, 3, 4 and 5. On the other side we have the Roman values. So 1 is assigned to, I'll just write over here that here it is first, second, third, fourth and fifth. Similarly in the Roman values, the number of stations. So 1 would be assigned to 1 in Roman, so it goes over here. Second is assigned to third station. Then from third it will go to fourth station, and from the fourth station it will go to the second, and from the fifth it will go to the fifth. So in this way the assignment is to be made. Then the minimum mileage, here they have given that the cost should be minimum, so as to minimize the total mileage. For that, whatever the assignments we have made, look for the original values in the table. Like for example, this was the question. The assignments are made, I am just marking here, it is 10, then it is over here 6, next it is in the third row fourth column, so third row fourth column 4, then fourth row second column, at last fifth row fifth column. So whatever the assignments we have made, we have to add these values, that will give us the minimum cost. So hence the minimum cost will be equal to the values 10 plus 6 in the order of assignment, plus 4 plus 9 plus 10. That gives me the value as 29. Now these were given in the form of mileages between various stations. How should the wagons would be transported so as to minimize the total mileage? So this will be the minimum cost. It may be in terms of rupees or any other currency. It means if we are reducing the mileage, we are reducing the overall cost of transferring the wagons from one station to another. So this gives us the minimum cost, and that is the final answer. And this value would be, it comes out to be, it is 39. It is not 29. The value is 39. So that's the final answer, and in short that was an explanation regarding the assignment problem. At the end, if you'll find my videos helpful, you can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.